Hi there everyone, and welcome to our session on business continuity and disaster recovery. My name's Andrew McKenzie and I'm joined today by my colleague and outstanding solutions architect, Kayvan. Welcome, Kayvan.
Hi Andrew, hi everyone who's watching. It's a very nice topic, Andrew, to discuss. Looking forward to it.
Now, Kayvan, sit tight because we're going to come back to you in a few minutes' time. But first, I wanted to set the scene with the viewers on what we're going to cover and a bit of background on business continuity and disaster recovery. So the key topics today will include the importance of business continuity and disaster recovery, BCDR. We all know we need it, but it's good to know all the variables that can help with your business. We'll touch on if you're an organisation who runs your infrastructure on premise today or in a third-party data centre, we'll talk about using the cloud for BCDR purposes. If you're an organisation who runs your production systems in the cloud, we'll touch on how you can use the cloud a little bit more in terms of optimising that BCDR scenario. We'll cover some key questions at the end and I guess help guide you how to optimise your BCDR current approach. So let's jump into it and focus a bit on the why, how and what. Let's just get our heads in the right space around why this topic is important. So according to Seagate, 22% of service disruptions are driven from human error. So we all know we need backup. We all know we need recovery scenarios. Things happen and it's just important. Everybody does it today. It's not anything new here. But outages and natural disasters, well, look, if you're on the east coast of Australia in 2022, certainly you know well about things like flooding and challenges that have occurred. There's been some significant storm events as well. You know, we're not a country that suffers those large-scale tsunamis and earthquakes as much, but certainly natural disasters, bushfires, floods, those sorts of things, big storms do have an impact. From a compliance point of view, it's an ever-increasing demand, and we need to constantly assess that our systems align with our compliance expectations today. And finally, ransomware, or we could probably broaden it to security, but you know, ransomware may have lost its place in the headlines, but it certainly hasn't lost its place in workplace impact. So I know statistics can be, I guess, used to paint a certain picture, but generally, if we just think about the magnitude of some of these, you know, figures on the screen here, we all agree that backup, business continuity, disaster recovery, they're all really important things. But I guess what's important is cloud has really changed the game. So traditionally, disaster recovery was complicated, it was complex in execution, but have you considered the modern possibilities that cloud brings to the game? Because it's really different. I remember the days of planning not just IT disaster recovery aspects, but also full-scale facility redundancy. So, you know, Kayvan, we had clients where I remember we had outsourced contracts to like IBM data centers, but not just for the servers, actually spaces for staff to go and sit if a disaster happened, right? Because mobility wasn't such a big thing in you know, years gone past. So people with desktops, if they got destroyed, they'd need a place to go and sit and work on those desktops. Now, look, if you are still in sort of a manufacturing type industry, then full facility DR may still be complex. But for most organisations now that have majority of workforce office-based and mobile workers, knowledge workers, you know, it's a really different game. It's so affordable and easy. From a rapid recovery, minimal data loss, you know, you can see on the screen here that recovery used to be, or recovery now can be achieved in less than an hour with only a matter of minutes lost, you know, should you need to go to your DR. Now that back in the day was, that was the realm of enterprise organisations, you know, typically financial institutions, health, defence, you know, and it was extremely expensive to get down to those what we call recovery point objectives and recovery time objectives, you know, and now it's easily attainable for everyone. Simplified testing, the cloud means it's non-disruptive to your production environment. It's easy to do, you know, be it for audit purposes, compliance needs, regular intervals for peace of mind. You know, that simplified testing changes the game. And the last one I'd say that really jumps out at me, Kayvan, is probably that accessible compliance, right? We don't have to worry about being caught out, that when we go to our DR scenario, you know, we're maybe not operating on that fully compliant scenario, right. You know, and what's the concerns around that? Because these cloud platforms, you know, have these, so many of them have these detailed compliance levels. You know, you can see there ISO and HIPAA and SOC and IRAP, etc. for Australia even. So really important to think about that modern business continuity and disaster recovery. Have you taken advantage of what's available to you? So we're going to talk you through some of that today. We're going to focus, you know, there's lots of different vendors and cloud vendors. We're going to take a look at the Microsoft Cloud examples for the purpose of this session. And we're going to talk about you're going to fit into one of these two camps, right? You either run your production systems on premise today, or maybe hybrid. Some of them may be on premise, and some in the cloud. And we're going to talk about second scenario where you're already in the cloud. How can we use the cloud further to optimize your BCDR strategy and performance? So there are two solutions. So we'll start with protecting to Azure. So you're an organization with systems on premise, either all of them or some of them, and you know, we're going to look at using Microsoft Azure here as a way to protect you. There are two services we're going to start with here. One is Azure Backup, and the second one is Azure Site Recovery, more for your disaster recovery scenario. So let's cover Azure Backup first. You know, traditional on-premise backup solutions require you to commission hardware, software, storage before you can back up your data. Over the years, you've had things like tape drives, be it DAT, DLT, LTO, and Kayvan, you probably know this, but I guess if you lose your production environment, you need to go and source a new tape drive to be able to restore your backup from the tapes that you've kept off site. So, you know, with the supply chain issues that we have today, available stock, getting that hardware in place before you start the restoration, you know, who knows how long that could lead to, I guess, before you back up and running again. So Azure Backup helps you to simplify your backup needs, and you don't have to over procure up front to pay for extra storage, right? It's simple. It's a simple, secure, pay-as-you-go model. You subscribe to it. You get billed for what you use. So Kayvan, you're an architect who designs these solutions, you implement them for clients regularly. You know, what are some of the key things you like about Azure Backup?
No, that's correct. Thanks, Andrew. Yes, you touched base basically about the backup and the needs. And as you mentioned, really backup is the first thing that every IT environment is going to need. That's a basic requirement for every IT environment. But it comes with many challenges. You briefly touched on some of those, but I just wanted to highlight what the challenges are. Usually, first is that you have to have some sort of a backup tool to take the backup, to schedule the task, to take the backups, to set all the retentions and deletions and all that, send the notifications. Luckily, we have good applications in that space, like applications like Veeam or Commvault or such applications are very helpful and can do that. Although they come at a cost and often a significant cost really, but they can actually simplify that level of the challenges. But there are other challenges as well, like one being the maintenance of the storage layer, which is whether you're using a server or a SAN or a NAS as your storage for holding the backups, ensuring that all disk drives are healthy and replacing them if there is a need for that. Usually you have to have some sort of a third-party maintenance contract with a vendor to do those replacements for you as well. And this is a challenge, is a cost as well, is a challenge for the admin layer as well. And another challenge is dealing with the large amounts of data that you have backed up on those storages. So business demands change over time. So does the size of your backup repository. So at some point you have to expand that backup storage, and the chances are you will hit some sort of a complication when doing that. For example, maybe the number of the disk that you can fit within one enclosure has a limit, and then you cannot go above that. Or for example, you may have to go and replace all the existing disk in your SAN storage, which was a smaller size, and change them all to a larger size, which that means that you have to copy your old backup inventory into the new one, and there's all complications of the data transfer, etc. as well. But once you deal with all these challenges and problems as well, and again, there is now many organizations need to have offsite backup. So all these challenges all over again to have the same level of the storage, backup, application synchronization in another location as well. So having all these in mind, like in summary, we can say traditional model of backing up and maintaining that is not really easy, and it's not very cost effective as well, because you have to have a lot of hardware to accommodate your future needs as well. That's where Microsoft Azure Backup can help us. Well, so that basically we can deploy this Azure Backup system for our on-prem environment. You will get unlimited storage space in the cloud, so you don't need to worry about the space and size and expansion, as well as the maintenance of those disks as well. And then you will get your backup and offsite replication all in under one umbrella of the Azure Backup. So no offsite application or anything like that. And the cost is minimum, because you are only paying for the amount of data that you are storing in the Azure for your backup environment. You are not overpaying for the storages for your future needs or anything. All the actual policies that dictates how much storage you have to use is adjustable. You can change them, adjust them over time as the business needs. So basically at a high level, that's how it is. But if we want to talk a little bit more about how it really works technically, there are mainly two ways of taking on-prem backups into Azure Data Center. Either you are using an agent called Microsoft Azure Recovery Service Agent, or MARS. That is like a little agent, goes on top of your servers, whether it's a virtual server, physical server, doesn't really matter. Or even, in fact, you can use that from your AWS environment as well. You can put that agent on your machine, and this agent takes care of compacting your data from that machine, encrypting that, and sending that over the internet into Azure Site Recovery, which will be holding your backup for future. That's method one, having the agent. The method two is actually having the Microsoft Azure Backup Server, or it's called MABS as well, which is basically one VM which goes on your virtual environment and orchestrate the actual taking the backup snapshots from the other VMs and transferring them. This is very useful if you have a workload with multiple types of different applications like SQL and Linux and Windows servers, or mixture of that, things like that. You better to have some this backup server in your environment as well. So another benefit of having this backup server is that you always are going to have the latest copies of your backup stored on-prem, because the way this backup server works is it takes the backup from your VMs and holds it on this server itself, and then from itself that MARS agent transfers the data from this server back to Azure. But at all point in time, you will have the latest recovery points stored on-prem on your server, so you can easily restore if it's needed. So now the backup data is in the cloud. Also, you can have different tiers of availability for that as well, which I'm going to talk about that later. But just keep in mind, not only you can back up your environment into cloud, even in cloud, you can choose how redundancy layers you can have your data in. So depending on your needs, we can choose the right solution and deploy that. Or for some organizations, that are using tools like Veeam or Commvault or similar products, they may want to keep that product. We can actually integrate that with Azure storage and basically only use Azure as a storage for those backup, for those applications. They can keep using their applications, but to get the benefit of unlimited storage and no maintenance for your storage layer, just use the Azure storage for your current backup application. That would be basically the actual main service, which does the backup for us. And then there is this disaster recovery one as well that I thought you wanted to discuss about.
Yeah, sure, Kevin. So look, great that it was good coverage, I think, of Azure Backup, and certainly a lot of people are familiar with those traditional tools like Veeam and others many others that are available in the market, and nice to know that things can integrate and work there together too. Look, I guess backup is one thing, right? And I think a big percentage of people have backup in place. Hopefully everyone, they certainly should. But disaster recovery maybe not quite the same level of uptake because of that cost and things that we've spoken about before. So, let's talk about Azure for disaster recovery purpose when we've got that larger scale disruption. Let's dive into a little bit around that.
Yes, sure. No worries. So for disaster recovery, very similar to the Azure Backup. In the Azure Backup scenario, we had our data and workload running from our on-prem environment in this scenario that we were discussing, and only taking the backups of the data into Azure. So for the disaster recovery, then the idea is you have to have another site, another location somewhere ready, all of your servers and critical business applications to be hosted in that site, ready to be activated when the disaster happens. So like in the old days that you had to, as you mentioned, you had to have a full operational site with infrastructure, networks, workstations, physical servers, storages, everything needed to be actually ready sitting in that site, and the replication needed to be in place for that, for the site to be able to use as a DR site. But now Azure Site Recovery comes and changes the game. So the way that they work is what actually it can deliver is this. It says that for the DR site, let's use Azure as your DR site, but you don't really need to have any infrastructure over there. All you do the initial setup and configuration, you do all the replication of your workloads and critical servers and everything into the Azure, but there is no infrastructure, there is no network, there is no any actual component, and that's really to minimize the cost, because if you're not running anything in the Azure, then you're not paying for anything. It's the idea is that let's just do the replication, and you pay minimum only for the replication of the data that you're doing, and whenever you do the failover into Azure, that's when your cost actually starts, and you only pay for the resources like servers and storages and network and all that. So basically, there are three main steps. One is that obviously the initial setup and replication, where you decide which servers on-prem need to be in the scope of protection, whether it's a VMware, Hyper-V, or even physical, doesn't really matter. Or again, it can be an AWS machine that you want to use Azure as a site recovery for AWS. You can do that as well. So you do the setup. There is one server that goes on-prem for your environment to do the orchestration of the replication, similar to the backup, and does all the replication. And these replication, when it comes to Azure, it just goes to an storage. It's not going to build a new VM or anything like that. It's just going to an storage. And then next stage is the failover. That's when actually the disaster has happened and you want to start using your DR site. So all the information that you have replicated to the Azure storages, but simply with a flick of a button, actually, you can start the failover process. That process automatically creates all those virtual machines and everything that you initially protected, and all those actually get created, the storages get attached to it, and then the network layer actually comes to life, and then your user can remotely connect to that environment and use the benefit. So you use that DR for usually a short period of time, maybe 1 day, 2 day, 1 week, until you get your current environment fixed. If there is a hardware replacement, you have to do that. Hopefully within a week time, 2 week time, you have replaced that. And now it's a time to fail back. So again, very similar to the failover, where with a switch, with pressing one button, you can actually fail back all these information that has been accumulated in the DR side right now in Azure back to your on-prem, and then everything can go back and the servers is starting on-prem yet again, and like in a normal scenario. So it's really a straightforward scenario actually here. I have one slide which shows things in a little more technical manner here. I just want to talk about that. Really, it's nothing different than what we discussed. You can see we have a workload of a few servers on the left-hand side, which is our on-prem environment. It can be a Linux, SharePoint server, or any type of server as well. And then this is our server, which takes care of the replication to the Azure side. And on the right-hand side, we have our failover side, which, as you can see with this within this dotted line box, these servers don't even exist initially. So initially, all is just a storage synchronization into this blob storage, and then from there, these VMs get created. So what this picture actually shows us is that there are other components. Azure Site Recovery by default doesn't really need any other component to work. Like you can literally sync your environment to Azure, and whenever you fail over, you can start using them. But there are little components you can deploy to take advantage of automations. For example, if you have a traffic manager sitting on top at the beginning before any disaster happens, that traffic manager can help you at the time of, for example, the DR activation, that automatically picks up that, okay, now the on-prem site is not accessible anymore, and it switches the traffic back to the Azure site automatically with DNS routings that we have done. Or even like a VPN tunnels that you can have in advance, just ensuring that your users, your site, or everywhere have the connectivity into the Azure site. So whenever the disaster happens, you don't need to worry about any other component, and all of them are already in place. So basically, that's at a high level what we can talk about Azure Site Recovery. And there are like benefits that I'm sure you're gonna walk us through that.
Yeah, look, thanks, Kayvan, for that deep dive there. And it's great how you showed there those different servers. They're not created. When you effectively need to use them, you can then turn them on in a production scenario as well. And that's when your larger costs will kick in, but they're still relatively small because you're not going to run them for a long period, maybe a day, a couple of days, who knows. But I guess to summarize, here's why you want to protect to Azure instead of building another data center as a failover location. First of all, you don't have to pay for that other data center and all those incidentals which lead to sunk costs, etc. You've dramatically improved your responsiveness and reduced your lost data risk. That PAYG means that you're, as we just spoke about, you're kind of reserving the right to use services, but you're not really even getting billed for them. Only the storage in that initial replication phase until you activate your DR. And then you're also, one other thing to consider is, if I'm not mistaken, you're kind of one small step away from operating production in Azure, right? Because you've actually replicated your production systems there. When you have a disaster, you're turning on and operating them. So you must be pretty close to operating in full production mode whenever you want. Is that correct?
Yes, that's exactly correct, Andrew. So basically, for many of the workloads that we do migration, let's assume someone wants to migrate from on-prem into Azure, we actually utilize the same tool, which is Azure Site Recovery. So in that case, when we deploy an environment, let's say it's one organization wants to use the DR site only from Azure, we do the ASR setup for them, and then the replication happens when but instead of a DR, let's say at some point they choose to go to fully cloud and eliminate and decommission the on-prem environment. All we do is that we activate the failover into Azure and then never fail back.
Brilliant. Excellent.
Yeah.
So thanks, Kayvan. So look, I think that's a good quick snapshot there around your on-premise. How do we use Azure for business continuity, disaster recovery purposes? Now, I guess you're an organisation. Let's focus. You're an organisation who already runs your production IT platform in the cloud. Let's look at BCDR again through this lens and what you might consider. So, starting with backup again. We already know Azure Backup it's a built-in Azure service. You mentioned, Kayvan, it's using zero infrastructure you kind of have to invest in. So what's the difference? You know, what benefits do you see when your production systems are in the cloud?
Correct. Yes. So Azure Backup is a native Azure service, right? And then obviously it can do the on-prem backup for us when it's needed. But because it has a high degree of integration with other Azure services, then we can utilize it in different areas. For example, when it comes to Azure, not only you can do your virtual machine and disk backup and things like that, you can actually back up other workloads, like if you have a web application running in an Azure web app, which is some sort of a platform as a service, IaaS service for web hosting, or Azure storages like Blob or Azure Files or anything like that, you can actually utilize this Azure Backup and use it there. The main benefit is really the simplicity, because it's a built-in component. Most of the time, it doesn't really require any IT admins to do any specific installation or any setup or anything. They just you go and set up the policies and retentions for how long you want to keep the backup, where you want to store it, and things like that, and bang, it's there. You don't really need to do any complex installation. The other benefit is really the redundancy. That's the very high valuable feature that comes to the table, that I want to elaborate more on that, but I just need to walk you through a few other things first so we can come back to this one. First, let me talk a little bit about how Azure services are hosting in general and how it's provided from different locations to people. So the first thing that we have is what Microsoft calls it an Azure region, which is basically a geographical location where the Azure services are being provided from. In total, currently, there are more than 60 different regions that are across 140 countries around the world. In Australia, for example, we have 4 regions, one region in New South Wales called Australia East, another one in Victoria called Australia Southeast, and there are 2 in Canberra called Australia Central 1 and 2. But then it goes a little further than just a region. In some regions, you get another level of distribution, which is called availability zone. For example, in this left picture, you can see this box is actually a region, it's called region A. And then within that, we have 3 distinct actually data centers. Each of them can be multiple data centers, which they are strategically placed far from each other to minimize the risk factors like natural disasters. For example, Australia East in New South Wales has 3 availability zones called AZ1, 2, 3. Now, going back to BCDR and backup subject, now we can utilize these regions and availability zone and all that in our favor and distribute the load and those backups in a way to maximize what we really need, whether it being a resiliency or any compliancy, data residency or anything like that, we can achieve that. For example, if we are doing a backup in terms of where we want those backups to be stored, we can actually store that on a locally redundant storage. That's where if you have some bunch of servers running in one of the data centers, it's going to be stored within that same zone, although it's going to have multiple copies of that within that data center anyway. But if you want to go one step beyond that, then you can go on zone redundant, which apart from where your servers are, your backup data will be distributed in the other 2 zones within that same region as well. So you have maximized your residency. You have maximized your resiliency while you have your data residency within the region. So these are the two types of the single region type backup, LRS or ZRS. And then if you want to go beyond that, you can go and say that I want my data to be replicated to completely another region, which is called dual region residency or geo-redundant storages. It goes to a GRS storage, and then a copy of your data will be in another paired region. So you can mix and match all of these ones for the purpose of your, not really just backup anything. For example, here, I was just showing that if you have a simple workload of, let's say, a web server, for example, and you want to host that in one location, instead of doing that, you can actually create 3 copies of that, keep that each copy in one availability zone within the same region, and then just put something like a application gateway behind that. So you have full resiliency against any sort of zone outages in one region of the Azure if anything happens. So you can mix and match these concepts, whether being for your business continuity, disaster recovery, high availability, or any of these purposes, and you can maximize your gain using these concepts.
Okay, so Kayvan, I guess we're on the last of the scenarios here in terms of disaster recovery. And it was a nice little bit of information you shared there around the availability zones and regions and those sorts of areas. Disaster recovery, I'm sure, is going to be able to leverage some of those. Let's take a look at that. So again, we've spoken about replicating to Azure from on-premise for DR purposes. And now we have all the aspects shown here on this slide, you know, that a modern cloud DR solution needs. So let's take a deeper dive into how it all works when you actually have your systems in Azure and you're still using Azure for DR. It sounds like it's probably not the right thing to do, but I'm sure you're going to tell me different.
Okay, basically, yes, again, exactly the same concept really, and same application really. Azure Site Recovery can be used to protect your on-prem environment, or even if you have a workload in Azure, you can protect that environment. And the way it works is, like, let me just show you in a simple diagram here. On the left-hand side, we have a simple workload of 2 servers running in your primary region. Let's say you have your Australia East, your business working in New South Wales. You have this workload of 2 servers running here in Australia East for you, and then you just want to have some sort of disaster recovery plan for any reason. And so what we do is that we deploy the Azure Site Recovery for you. What happens is we choose which location we want for our to be our DR site. In this case, we have chosen Southeast in Victoria to be our DR site, and then we are replicating these VMs into that region. As you can see, there is nothing actually gets created in that region. All the availability sets, network, and everything is blank. You're only having just the disk copies of these VMs replicated. That's to minimize your cost in that new DR location. And then let's say disaster has happened and you no longer have access to your primary region for any reason, and then we initiate the failover and all your workloads gets created on the destination location from these disks that were in sync. This is very straightforward actually, and when I say simply by failover, literally it's just press up one button called failover. You don't really need to do anything else on top of that. We have this like in a more kind of complex diagram as well, but it's really exactly the same thing. It's just showing that you can have multiple tiers of applications. Like let's say, for example, you have web servers, app servers, databases, and even they are within availability sets within their own region. So all this diagram is showing is that you can maintain having those sets and everything in your DR site as well. And then something like Traffic Manager, for example, orchestrating the connectivity between the source and destination, instead of you needing to be worried about changing DNS records or things like that at the time of failover. These can come and automate those ones for you. So that's at the high level, it's that you get your servers, you synchronize them to another location, and then use that at the DR time. But another good thing is that there is some built-in feature called failover testing. This is basically, you know, that as part of backup or DR, you don't really have your backup, or you don't it's not considered as in operational DR, operational backup, unless you test it once or twice minimum a year. So because of that, site recovery has done a good thing, and they have included this failover testing as a feature. Basically, what it does is that you have your primary workload running, let's say whatever it is, application and a database, for example. That can keep running in your production side without any impact to anyone. We can actually test failover those two applications or those two servers to your secondary region, bring them up in kind of an isolated network that no one can access, and we only allow some UAT people to be able to access that and test the actual application. We bring that up on the DR location. Some from people from IT or UAT test go and verify and validate that DR server is accessible and operational in the way that they want. And once you do that, even there is a button to say clean up test failover environment, and then that removes that test VMs and all those storages created for that, and everything back to normal without any impact to the production environment at all. That's one good feature from site recovery, but the most powerful part is what is called recovery plans. This is where I've seen many organizations can hugely benefit from Azure Site Recovery. And what it is, it's basically it's a layer of automations on top of those failover and failback components. For example, we have a client right now that they have very sensitive ERP system, that the servers for that ERP system needs to be started in a certain order. Like, for example, first application and then database, and it has to be a very specific order for that. So with the recovery plans within the failover to DR side, you can choose for your servers with what order they have to start. You can actually create multiple plans. Let's say you have multiple workloads, one for your Citrix environment, one for your RDS environment, one for something else. You can actually separate them and only initiate the failover for your RDS environment only. And you can choose that, and it automates many stuff. Yeah, you can put PowerShell commands or scripts to run during the failover, so it goes and runs that. Or for example, you can say, go and update this DNS record here, or go and change this SQL string, connection string here and there because this connection is to a new site, or even simply just show something on the screen and like a pre-written message to the IT, whoever is initiating the failover. You can come on, you can bring something on the screen to say, okay, like now that you are initiating DR, go and update this IP on this server. You know, you can just put a text for them just to read. So at the time of failover initiation, they don't need to really think about other things. Everything is automated for them in front of them, and they can benefit from that. That's pretty much all I had about the site recovery and the automations on top. I hope really that was covering.
Yeah, that's great, Kayvan. Look, I guess, you know, when you're in that recovery scenario, right, the pressure's on. There's that risk of potentially making mistakes or not thinking things through. You've probably got people yelling at you, how come the system's not back up? So I really like the idea of that recovery plans. You know, that potentially takes that risk away from things, because ahead of time you've planned it out, thought of the sequencing and things that need to be done. So very, very cool. And I guess with that testing, you can test one server by itself. You can, you know, test multiple servers and systems. You can run that with internal resources pretty effectively by the sounds of things. But if you don't have IT resources, then because it's pretty straightforward and easy, it's not going to cost a lot to, you know, have somebody like a managed service organization like ourselves doing that for you. So it sounds like a win no matter what your setup is there. So yeah, excellent. All right, let's just jump into some quick questions then, Kayvan, because you know, we're heading close to time here, but we probably have a few things that are worth going through, and then we can focus on what you can do next. But so from the questions point of view, the first one here, does site recovery need internet connectivity? Now, I would have thought, Kayvan, that all servers, if you're going to run it in the cloud, you probably need internet connectivity, but this question might be angling at something different here.
So basically, the answer to this is yes and no. In reality, you are transferring the data across internet into Azure Site Recovery, but in many organizations, they don't even allow internet access on the servers, and they block the internet access for security reasons, which is well known. Because of that, there are certain URLs from Microsoft. As long as we have access to those URLs and they are whitelisted, then yes, we can run the Azure Site Recovery, similar to how you do the patching for servers. You only allow specific URLs like Microsoft update and things like that allowed. For Site Recovery, there are same things, and as long as we have those allowed, and then the servers don't really need a separate internet.
Perfect. Okay, next one. Are all recovery points a complete virtual machine copy?
Okay, so basically, when we set up the site recovery, a copy of this VM gets created, like that, it gets replicated to the Azure. That the first copy is always complete, just to ensure all the data from source has come to the destination. But from that moment onward, just to ensure that the DR location data is up to date, all the changes are just the delta changes. So whenever something changes on the source, the same gets replicated to destination. And keep in mind that is constantly happening. So at any point in time, you have the latest data in the Azure, but you don't have it as a kind of one VM. When you do the failover, all those recovery points get consolidated and one VM comes up, and then that would be the latest changes on your on-prem environment.
Yeah, great. So certainly reduces cost on bandwidth and those sorts of things, because it's really just the deltas that are happening.
Yes, it's a delta, and on top of that, all those replications, it compresses the data. So the server that we have on source, it grabs the data, compresses that, encrypts that, and sends it over wire to the destination. So really, if you have a 100 gig server on-prem, not necessarily you're using 100 gig to replicate that to destination.
Yeah, and look, it's pretty much, as I understand it, trickling almost continuously anyway, those changes, because of that's how we get down to just a few minutes of data risk, So, okay, interesting question, this one. How far back can I recover from?
Okay, so by default, when we deploy the site recovery, all the information are synchronized, as I mentioned, constantly. But you can choose and say it's in your hand to choose how far back you can recover from. Most of the time, everyone wants the latest copy, right? And as you mentioned, it's often in a matter of minutes, like let's say 5 minutes before or 2 minutes before or 10 minutes before. But in some cases, you may choose to recover from a few days back. Maybe there was a weekend and there was some data or something, happened on the weekend and you didn't realize until Monday, and then you want to go back all the way to the Friday. So because of that, you have the flexibility of restoring up to 15 days ago. So anywhere from 0 to 15 days is what you have to, you can. But keep in mind, the more recovery points you keep in the cloud, the more storages you are consuming. So if the intention is to reduce the cost, that should also be in line with that. Usually, like somewhere between 2-3 days would be enough for most of the businesses, because that covers public holidays and weekends as well.
Got it. All right. Do I need to worry about security when using the cloud? So I guess this is maybe coming from people who haven't used the cloud before. They feel comfortable with their own environments. How do we reassure people around cloud security?
That's really very valid concern, to be honest. That's a very valid thing to talk about. But for the Azure Backup and Azure Site Recovery, both of them, they have so multiple levels of security built in. So one is the encryption, obviously. So all the data in transit and at rest, both of them are encrypted. So when you're sending it over internet, it's 256-bit encryption key, which is like very high level compared to like many of the IPsec tunnels and the VPNs that we have is less than that right now. So it is encrypted while it's transferring, and when at rest in the destination in Azure, then it is also encrypted using a key from Microsoft. And so this is for the data itself, but to access that authorization, to access that as well, obviously you have to choose which admin, for example, can access those ones. Like if they have their own identities within Microsoft Azure Active Directory, you can choose which admins can have that access. You can enforce things like multi-factor authentication on top of that to allow or disallow the access to that. And recently they have enabled the PIN code access as well. So you can say, even if you have 10 admins, only one admin can access the backups, and they are enforced to do their MFA and PIN code as well. And then on top of that, you get full audit report of the audit logs of who has accessed what at what time and when and what exactly they have accessed. So you get all the features of security that is usually expected.
Yeah, fantastic. And look, I guess to add to that, Kayvan, you know, we already touched on the point around the compliance of the Microsoft data centers, and they don't have access to your data. It's just the systems that operate it, and they've got all that IRAP and ISO compliance and all those things that you need. So for most organizations, it's probably more secure, you know, in Microsoft Azure. Okay, last one we'll throw out question-wise here. Can I keep server IP addresses after failover?
Yes, this is one of those risky questions, really. I've seen many environments actually, they have some sort of a old application or legacy application that some IP addresses are hard-coded in the app, and it's not easy for them to get rid of that. So unless it's any of those circumstances, we shouldn't really think about keeping the IP addresses. It's better to have separate IP addresses because it gives you flexibility. But if you have that restriction, the good answer is yes, you can. You can keep your on-prem IP address in the destination as well. You can actually, in fact, create your Azure network exactly same subnet and same everything as your local on-prem environment. And whenever DR happens, as if nothing changes, same IP address, you can reach out to those servers in the Azure environment and everything. But you are losing a few other things, which would be the flexibility. For example, running some of your servers on-prem, some in the Azure. But in that case, if the Azure has all the IP addresses, then you have to use one or the other. But technically, yes, you can.
Terrific. Thanks, Kayvan. It's always great the knowledge that you bring. So hey, let's wrap up for the crew watching here. Look, what do I do now? You've watched this session. Modern business continuity, disaster recovery is something you're thinking about. It's appealing to you. Well, I'd say, first of all, just maybe review these questions on the screen and consider if you have the best systems in place to face an outage. So how long will it take to restore your production systems currently? What's your current RTO? How much data do you risk losing? You know, what's the current RPO? I spoke to an organisation recently, spending a significant amount of money per year, and they're sitting at something like a half day to a day recovery times. You know, they could probably pay a tenth of what they're paying and get it down to the minutes we've spoken about. What is the impact to client trust if downtime occurs? So I think that's a really important one to consider. Everyone has social media these days. Not much is private anymore, even in the commercial world. We need to understand the risk and impact. Do you rely on sourcing hardware to recover production systems, as we spoke about in current supply chain experiences? I'd be concerned if that was the scenario, and I knew I had to recover. How many users are on your network at any given time? That can really determine if you've got sufficient bandwidth and those sorts of things, and can tolerate the failover on your current DR systems. Have you outgrown it? I guess is a question relating to that. Are you compliant if you're running on your recovered system, like we spoke about? And the final one here is probably not so much assessing your risk, but more assessing, where you're heading, cloud strategies. What are your considerations for future, and how does cloud map into that with the DR conversation is important. So look, we've put a couple of things together here just to help you. If you're still exploring Azure, keep in mind that we can offer a free consultation to review the options for you, provide you high-level modelling to help suit your specific requirement and help you with a business case. Incidentally, if you're a not-for-profit organisation, you're watching this call, Microsoft offer you a $3,500 Azure credit for you being a not-for-profit organisation. So we can help you understand how best to utilise that. If you're already in Azure and you're really looking at optimizing your DR scenario using the cloud, then we can provide a free high-level Azure optimization review and your next steps around that budgeting and planning and business case assistance in that scenario as well. So if that is something that you're interested in, please use these details here to reach out and connect with us. Kayvan, myself, or one of the team can work through that with you. But as for today, thanks, Kayvan. It's been great having you here. And thanks, everybody, for watching. We hope you join us again soon for one of our future topics, and appreciate your time. Thanks all.
Thanks, Andrew. Thanks, everyone.